So this video is for AP Statistics Chapter 1, and this is going to be the introductory concepts of the textbook, just kind of basic terminology and vocabulary. The first thing you need to know is variables. So we have two different kinds of variables. We have categorical variables, and categorical variables are going to be things like gender, what state you live in, race, all sorts of things that you can't count, something that you're grouped by. And then we're going to have quantitative variables, which are numerical values, for example, what age, batting average, and points scored in sports, stuff like that. And so something to keep in mind, kind of a trick, is, so for quantitative sounds like quantity. Quantity is the number of something. So think quantitative number. So it's numerical values. And something your teachers might try to trick you up with is they might throw in a variable, say, zip code. And for something like zip code, this is going to be actually, despite that it's a number, say the zip code 94026, it's actually a categorical variable, because you can't add up a bunch of zip codes and then divide by it to get your mean and then average out zip codes. That's not going to work, because zip codes are based on, it's just a list of numbers to show where somebody lives, what city they live in. So zip code, despite that is based off of numbers, it's actually a categorical variable. So keep that in mind for other things like telephone number, area code, that sort of thing. The next concept is going to be, how can you describe a set of data? And how people do this is they use the mean, the median, and then there's several other statistics. And so the mean is pretty standard. The mean is you sum up all your observations, say x1, x2, you add it up, and then you divide by how many observations you have. So if we have the data set 1, 2, 3, 4, we're going to add up 1, 2, 3, 4, that's going to be 10, and then we're going to divide by 4 equals 2.5, so our mean is 2.5. And then the median is the middle piece of data. So something to keep in mind is that it's going to be different to calculate it based on if the number of observations is odd or even. So here we had 4 observations, and so there isn't a middle number. The middle numbers are 2 and 3, and so what you do to calculate the median, if it's an even number, is you take these 2 middle numbers and you average those. So for this, the median would be 2.5, because 2 plus 3 divided by 2 is 2.5. But for example, if we had the data set 1, 2, 3, 4, 5, our median is going to be 3, because there's an odd number, there's going to be one middle number. And something to keep in mind, there might be questions about, is resistance. So the mean is non-resistant. And what this means is that if you add a bunch of outliers, so say the data set is 1, 2, 3, 4, and we add on 100, the mean is going to go up a number, because we're adding this huge number at the end of it that's going to cause the mean to grow larger. But if we're calculating the median, we look at what's our middle number. Our middle number is 3. So the median stays the same, even though we had this huge number at the end of the data, which is obviously an outlier. But the median is going to stay resistant. And so also another concept to know is standard deviation. And standard deviation measures how far the data is from the mean. And our equation is s squared equals your observation minus the mean squared, and then you add this up for each observation, and you keep on squaring it until you run out, and then you're going to square root it, And then also, before you square root it, you're going to divide by n minus 1. So that's your number of observations, and then subtract 1. And so the variance is standard deviation squared. So if you didn't square root this, you would just have the variance. But to find the standard deviation, you have to square root all the sums as you square. And then now we have degrees of freedom. Degrees of freedom is, you're going to use this more later on and when you do chi-square tests and t-tests, but for now, degrees of freedom is n minus 1, so that's your number of observations, and then you're going to subtract 1 from that. And then also, I'm not sure how your teacher does, whether they require you to memorize all these different formulas or whether you just need to know what each one means. But if you want to double check your statistics, you can always use your graphing calculator. I have a TI-84, and so what I do is I just do, the first one is stat. You go to edit, you put all of your data in L1, and then you're going to press stat again, calculate, and go to one variable statistics if you have one group of data, or if you have two groups and you need to compare the frequencies, you can do two variable statistics, but usually for right now, what's pretty standard is just one variable statistics. And so yeah, you can use that just to check your answers, or if your teacher doesn't require that you know the formulas or do it by hand, you can just use it on your graphing calculator, and it's a lot easier and a lot more accurate. And then also a concept that we need to know is for when we look at graphs, say this is our graph here, is center, shape, and spread. And so the center is going to be the approximate median of the graph, roughly the center. So our center is about here. And what this means is about half the data is on this side, and about half the data is on this side. So this is your median, your center. And then the shape of the graph. The shape of this graph is roughly normal, just because the center is in the middle about. You can have other graphs with skewness, different curvature. For example, this graph is skewed right because there's a lot of concentrated data over here and not that much over there. But you don't really need to know different skewness until chapter 2. Just know that this isn't normal. This is skewed. And so then also another concept is spread. So spread is the length of the data groups. So if the data is, all the data is in numbers 1 through 5, that's a pretty small spread. But if it's 1 through 100, you're going to have a lot larger spread, a lot more variation between figures. And another thing to know is range and quartiles. And so your range is the maximum data point you have subtracted by the minimum data point. So if we have the numbers 1, bunch of random numbers, and then our maximum is 100, the range is going to be 100 minus 1 equals 99. So 99 is going to be our range. And then quartiles measure kind of percentiles of where the data actually is. So what we use is we use the first quartile and the third quartile. So in the first quartile, 25% of the data is below that point. So if we have, let's say our data set is 1, 2, 3, 4, 5. We're going to look, see what's the, at what point is 25% of the data below. And so you can look and see, okay, calculate it, put it in your calculator, and you'll see that Q1 equals 1.5 and Q3 equals 4.5. And so we have this number 1.5. 25% of the data is below that number. And then we look at 4.5. It's not actually a data point on there. You have to average it. There's not that many numbers, but 25% will be above and 75% will be below. And so to calculate quartiles, you take the median of the observations from left and right of the median. So here's our median, so let's just box that out. So now we have these two numbers to the left. So we take the average of, we use the median, and so there's only two. So we take the average of this, and that's 1.5. And then to the right, we take the average of this because there's only two numbers, and that's 4.5. And so really when your quartiles are going to be of use to you is when you're creating different graphs. For example, there's a thing called 5-number summary, and that's used when you create box plots. And so your 5-number summary is going to be your minimum, your fourth quartile, your median, your third quartile, and your maximum. And so, okay, so now we have outliers and the 1.5 IQR rule. And so we just talked about quartiles, but an outlier is just, you've probably heard the phrase, the word before, and it's just a piece of data that's outside the normal range. So if we have, let's say, a group of numbers here, and then we just have a random number over here, we're going to call this an outlier because the normal range is about here, and that's far outside the normal range. And so how can you see if something's technically an outlier, or maybe it just looks like an outlier and you're not sure? Well, there's a rule called the 1.5 IQR rule. And so you're going to take your interquartile range, which is the third quartile minus the first quartile, and then you're going to multiply that by 1.5. So let's say Q3 equals 10 and Q1 equals 5. We're going to find our interquartile range, IQR. We're going to do 10 minus 5, 5, and then we're going to multiply by 1.5 equals 7.5. So our 1.5 IQR is 7.5. And so how do you use the rule to see if something is outlier? Well, you're going to look at your Q3, and so our Q3 equals 10. So if we're going to take our 7.5, and if a number is above 7.5 plus 10, if it's above 17.5, then it's considered an outlier. So when you use the rule, you're going to add your 1.5 IQR to the Q3, so Q3 plus 1.5 IQR. If it's above that, then it's an outlier. Or if that's kind of the top range. Or if we look at the bottom, we're going to take our Q1 and we're going to subtract 7.5 or whatever your 1.5 IQR is. And so that's it for chapter 1. There's another video that's going to be on basic graphing. But for this is your basic concepts of chapter 1.